Hey everybody. Today we're going to talk about location, the greatest attribute ever known. And a lot of this is kind of getting back to the basics. So it's going to be a little different than some of the other presentations you may have heard today. But before we get started, I just wanted to take a second to kind of recognize the Energis crew. I mean, all these folks volunteer their time. It's an amazing group. There's so much talent. There's just so much knowledge with them. I've been with them. This is my third year on the Energis board, and I'm amazed every time we have a meeting, just the collaboration and those type of things. So if you don't mind, if you just round of applause for them. And if you see them, just give them a pat on the back. It's a lot of work to put this together, and I think it should be recognized. So let's start. Thanks for giving a little bit of my history. I wanted to touch on just a few notes. I've been doing GIS for 28 years. I've been doing everything from PCR info clear through enterprise. I've spent 18 years at the largest electric company in the US. And when I started there, I was doing data entry. And when I finished, I was doing, enterprise vision. We had a lot of assets, obviously, it's a big company. And my specialties include Esri Enterprise and AGOL, office to field and field to office workflows and solutions, and the GIS vision strategy and integrations. So, start off, electric and gas. A lot of my examples are going to be kind of on the electric side, but when it comes down to it, it's really the same thing, right? We're all doing basically the same stuff with points, lines, and polygons. Whether it's electric, gas, water, whatever, it needs to be planned, scoped, engineered, accessed, constructed, operated, maintained, and they both interact with the environment and all those type of things. So attributes. Back in the 1600s, the gentleman that created latitude and longitude that you all might know about was quoted as saying, "We do not describe the world we see the world we can describe." And what that means to me is, we use these attributes to describe these things, places, and events that happen. And that's kind of what we're doing, on the back end of GIS, right? All those attributes that we're kind of adding to things are basically from that. So kind of like how a field guide, so field identification guides have been around, for before computers, right? Everyone had their field identification guide when they were out in the field. You have your scientific name, which might be like your unique ID, and you have your common name, which might be your asset name. I mean, you have all these attributes. You got pictures. You got even almost every one of them has some sort of map to kind of tell you the region or where it's at, which a little foreshadowing, location might be important. The types of attributes. So this is the way I look at attributes when I talk to a client or I'm working on a solution. I don't really care about whether it's text, numeric, whatever. I kind of break it into these types. Keys, groupings, statuses, numbers, dates, location, geometry, notes, and ancillary. And with the two key ones, or the two main ones being keys, obviously, the unique ID is probably the most valuable attribute. But the greatest attribute is your geometry and your location, that point, line, and polygon. And the reason for that is it can answer lots of questions. It's not just one attribute that's there. If you have that information, you can answer all these other questions in the future that may not even be or not even being asked at the present. It's something that they need in the future. But there's also got to be some thought with how much detail are you going to go with this? Are you going to just collect a few attributes, or you're going to collect every single thing you can think of to try and describe this thing that's out there in the world? And there's a cost to that. If you only do a few, you may not be able to use that information later on, as much as you want. But at the same time, if you do too much, now you're spending a lot of time trying to keep that up to date, which can be very expensive. Points, lines, and polygons, right? So Roger Tomlinson, many of you may know him or know of him. He said, "It's impossible to map the world. We select and make graphics so that we can understand it. And those graphics we use are points, lines, and polygons." And I know a lot of you know that, but sometimes it's just good to kind of come back and go to the basics and really think about it. And that's what we described for what we use to show these for places and events. Now, when I was back in school, like I said, I started with PCR info, which is command-based. It was way different than like your ArcGIS Pro or even ArcView that many of you are used to. But in the brochure back there in 1982, I wasn't in school in 1982, but just to show you when it came out, that was the brochure. But they talk about it, right? They break it down, points, lines, polygons, and how they are the containers for attributes, right? We use these features, and all those attributes are kind of contained in that point, line, and polygon. But it's also just like attributes, right? You have to decide how much detail am I going to go into. At the electric company, when I first started there, we had all our stations as points, right? So at small scale, you could see all these points. You could attribute them. You could symbolize them based on, any kind of status or those type things, and it worked pretty well. But I also had engineers coming to me saying, hey, I want to get my entire, PLS-CAD model or my microstation model in the GIS. And some of their stuff was clear down to, threads on the bolt, which to me it's overkill, right? That's a lot to maintain. That's a lot to keep track of. So for me, it's kind of somewhere in the middle there is kind of the sweet spot, but it all depends on the utility. It all depends on the customer and what they're looking for. Also in that brochure that I mentioned from 1982, you probably can't see it here, but right down here, they start talking about network. So maybe you've heard of utility network. It's not a new thing. It's been around for a while. They've known that linear assets need to be networked because you're pushing things through these lines. They're just not lines and points. They're actually you have electricity, you have gas, you have things going through these things. So there's that logical network that's beyond the physical network. And one more thing I just want to show there, because you got to have a picture of Jack back then, and it just made me laugh. So that's back in 1982. There's Jack and team. So we've talked about attributes. We've talked about the geometry. The next thing we need to talk about is software, right? So whether you use Esri, QGIS, Small World, whatever it is, they all, at their core, they answer questions about points, lines, and polygons and the attributes they contain. So it doesn't necessarily matter what software you go with. I have a preference. I'm a Esri guy, even though I've worked with all of these. I tend to go towards Esri, but it really doesn't matter. Again, it all does the same stuff, and it's the same for all companies, right? You don't go out and Esri doesn't say, okay, here's your utility version of Esri, or QGIS saying here's your your banking version for the banking industry for QGIS. You're purchasing the same thing that every company, every industry is getting. And it's really up to the company that purchases the GIS and invests in it to configure it for their points, lines, and polygons of their company. So I said it could answer questions. I'm not going to spend a lot of time on this because I know we all know what kind of questions GIS data can answer. But the main thing I want to get here is let's stop hand entering location attributes. You see it everywhere. So even when I work with clients, they'll give me a spreadsheet, they'll give me stuff, and you're looking at it, and here's an example of one, with these GPS coordinates that were hand entered, and it's like, why are you hand entering them? You're out there in the field. Why didn't you grab the location, while you're out there? Why didn't you grab, what asset you were buy automatically just based off of your location? Why are you forcing people in the field and in the office to fill these things out? You don't need to. There's better ways through automation and those type of things to do that. It can also answer the past and future questions, and I'll just give you a couple examples that came up, when I was at the electric company. The first one, there was a study they wanted to do. Okay, what stations are in flood zones? And to be honest with you, I kind of figured they would have figured that out when they were building the stations, but they didn't. So they wanted to kind of look back and see, okay, where do we need to kind of raise our stations to kind of get them out of the flood zone? And we were able to do that. It's an easy spatial question to do, and we were able to get that answer, very quickly. The problem was, again, we were using points for those stations. So, and flood zones are polygons, right? So if I got a point here, and that flood zone's actually going through the station fence and going through that station, but the point sits outside of it, it's not going to show that that's in a flood zone. So I had to tell them, hey, maybe we need to get a little bit more detailed with our station information so we can start to do more with it. I'll skip structure and line and go straight to AI and machine learning. A good example with that is, you can do all this machine learning to I'm going to take a picture of a tower, and I want machine learning to kind of decide, okay, here's the status of it, and here's the condition of it, and maybe this crossarm's broken or whatever. If you feed GIS into that and you have good location data, well, now all that stuff that it can't see, right? All that stuff that's just not there, like the name of it, the unique ID, when it was installed, all that stuff can start to feed in there, and it really opens doors, to really push that data beyond, what it was initially intended for. So you have all that. Now what do you do? Well, big thing I see with a lot of companies is they don't know what their core layers are. You got a bunch of people putting a bunch of layers into the system, but what are the core things? What are the main things you're interested in? What are the main things, the main geometry that you can kind of reuse depending on the department, to kind of add your attributes to and do your analysis with? So the study I did, at the electric company was, okay, to me, tier one, the most things that I get asked for are station structures, the physical lines, and then the logical circuits, and then the system boundaries. That makes sense, right? Well, tier two would be your core details, station fence. Okay, now you're getting a little bit more detailed. Where our meters, our interconnects, where's our right-of-way and access roads? And a big one being, contacts. I don't know how many of you have just a contact layer in your GIS. Someone out in the field has an issue. Who do they talk to? Who's the right-of-way agent? Who's the PM? Who's the engineer, that engineered this thing? People can spend a lot of time looking for that. And a simple contact layer can really solve that problem. And then tier three is now you're really getting down into the nitty gritty, right? You got, where are my customers, my station equipment? We had a thing called Code Red and Vicious Dog. So that was more of like a safety thing for people on the field. So we knew where past events had happened and we could, have police escort and things like that if need be. Stop, no work, permits, soil borings, LiDAR, all that type of stuff. But basically what it boils down to is, where are my assets? What's the sandbox that I'm in that I need to worry about? And then how do I access those assets? Those are the key things you really need to think about. And then I got a chance to look outside of transmission. I was able to kind of do the vision and things for GIS for not only transmission, but generation, distribution, and telecom. And what I found is it's all the same, right? It's linear assets have the same problems, the same things that they're trying to solve, and it's assets, boundaries, and access. Okay, we talked about all that. Now let's talk about organizational structure. You've heard a lot of people talk here today about silos and how those are issues. It was an issue for me. I'm sure it's an issue for you. Each of these silos, each business unit, whatever you want to call it, department group, they all have their own management style. They all have their own workflows and standards, and it can be difficult to keep up with them because some of them are better than others. One of the common things about each of these silos is they're all looking at assets, right? What are we really doing? Well, we're all working with assets. We're providing, our attributes, our piece of the puzzle, about that asset for other people to use and not only for us, but, the key attributes for other people to use for that. And it's also linear and temporal. It's throughout the asset life cycle. You just don't put it there and then you walk away and you're done. You got to plan things, you got to build things, you got to maintain and operate things. So all those times at different pieces of time, you're feeding these different pieces of information. So the commonality between all of that, as we all know here, is location, right? So your planning, scoping, siting, right-of-way engineering, procurement, construction, and maintenance groups, they all rely on that location. So if you kind of focus on location and it's kind of a location early type attitude, instead of bringing GIS late to the party, as we usually are, you can get a lot more out of this because, again, location is that commonality between not only the asset, because all those assets have a location. Now, one thing you won't see on here or on that, with all the silos going around is operations. Operations, most groups use GIS. Operations use ODMS, Operation Database Management System, and they use the logical model versus the physical model. They use one lines instead of, CAD drawings and those type things. And really the only groups that are talking to operations are, your planning and station engineering groups and maybe a little bit with your line engineering group. And just to give you an example of that, this was our transmission center and this was our operations center, and they literally built a moat around the operations center. That's how separated they were. And I was there for, I bet, a good 12 years before I really understood what. They might as well. There is a bridge. It is its own security. It was its own everything. It was a sight to be seen. So what I learned, again, it took a long time for me to kind of crack the code of why operations was so difficult, why we had so much trouble, getting that meter data and the outage data and those type things that we could show in GIS. They always fought us on it, and I never understood why. And then finally, it kind of clicked, and I figured it out. I got to be, friends with a couple people in operations, and they were able to explain a lot to me. And so with that, I kind of broke it down. Okay, we're kind of doing things in 4 views, right? The tabular view, you all know. I mean, that's pretty much every silo has some sort of tabular data that they're feeding into either their system or a central, data warehouse or whatever you want to call it, some sort of system of record or system of truth. You have your asset data. That's the what. That's the thing they're building, or at least designing, that they want to be put out there in the real world, and that's super detailed. Like I said, down to the threads on a bolt. And then you have the geographic view, which is kind of, if you think about it, it's that mosaic view of both the tabular data and the asset view across your entire system. And that's the beauty of GIS, right? It connects all those thousands of drawings for all these assets, and it gives you one big view of it, where you can go small scale or go clear into your large scale views. And then the fourth piece that a lot of us don't think about, and I call this the electrical view, right? This could be gas, it could be whatever. But the point being is they use one lines to design their stations, and then they feed those one lines up to, or the station one lines up to a system one line. And it's still points, lines, and polygons. But what I figured out was years and years and years ago, engineers and whatever, people working in operations, they figured out that it's hard, right? It's hard to know when to turn something on, when to turn something off, for that electricity going through the lines or gas going through the lines, whatever it may be, that logical thing that's going through there. That's a hard equation to solve. So how do you make something easier? Well, you piece it out. You take something out. Well, they took location out of the equation, and it made things a lot easier for them. So when you go into operations, they don't really care about the lines in between the points. It's just, here's what we have in here, and it should work if it's going from this point to this point, and it's just a straight line for it. They don't care about hills it's going over or rivers it's crossing. It's not really a concern of theirs. And again, it took me a while to figure that out, because one of the people that fought me the most when I was trying to get projects approved and trying to get funding was our head of operations. He fought me constantly. And it took me a while to kind of figure out, okay, I need to change my message. I need to change how I'm talking to them in order to get these projects approved and teach them why location is so important. All right, the next 3 are going to be things that I kind of find, they can either crush a GIS or they can really give it a superpower. And integrations. Give you an example. This is Procore, and I'm going to pick on Procore just because a lot of people use it, and I have my issues with it. But our planning and our project management group were looking for a way. They needed to get the project life cycle and how they were going to store everything in kind of one place, and they chose Procore. And I went to him and I said, hey, you guys really need to think about location, because it's an important thing of what we do, especially at the beginning of a project. And they said, hey, Mike, don't worry about it. Who we went with, they have an integration that'll, let us plug the GIS right into it. And it's like, man, that's awesome that they have an integration. Pretty much every enterprise system that you see out there that's not GIS is starting to get some sort of spatial piece to it. Something that you can plug GIS into. The problem is that data doesn't come from magic, right? It just doesn't appear. So you still have to have workflows, you still have to have standards, you still have to have things in place to feed it. It just doesn't happen just because you got something that had an integration. Standards and enforcement. This is another huge thing that I don't think a lot of companies think about. We have engineering standards, and you have all these standards throughout the company of how the data needs to be structured, but in GIS, we don't have a ton of standards. We just don't have the people. We don't have the time. We're we're flying by the seat of our pants, just trying to keep up with everything because the technology keeps changing so much. But at the end of the day, it's junk in, junk out. And if you don't have the standards in place, it's going to be a rough road. And not only standards, but you have to have the enforcement, right? What's the point of having standards if you're not enforcing what you're saying they should do? And also, you're either going to invest in standards and enforcement, which will get you closer to kind of that automation side. But if you don't have standards and enforcement, you're going to be investing in more people on the manual side because you're going to still have people update their data and plug it in and kind of check it out. The third thing is ownership and governance. So if you were here last year and you heard my presentation, there was a slide I had here kind of talking about Esri Enterprise, going from the BU workflow clear through the apps and the user and so forth, kind of that flow, of the Esri Enterprise. And one thing that I see constantly is, people will make changes upstream that affect downstream things. So those core layers I talked about, if engineering decides, hey, we're going to change the domains or we're going to change this field because we need to change it in our silo, they don't think about how that affects other people. And sometimes they don't even care, right? They're like, it's our data, we're going to do whatever we want with it. And that's not good. So ownership and governance is a huge piece. Now I'm going to jump to a little thing I like to call GIS Jenga. And this is basically my last year at the electric company. This is what I felt like it was. So GIS Jenga. So back in the day, utilities and energy, we were early adopters, to GIS. So there wasn't a lot out there for them to structure based off of, other than, again, points, lines, and polygons and what attributes they knew at that time. And a lot of times it started in engineering, maybe planning, and so it was kind of revolved around that. So at the beginning, you probably had a consultant install it for you, and it had that new GIS smell, and everything was all great, and everyone was all happy. And then, over the next few years, holes got poked, and it got restacked, and resources got moved around, and needs adjusted. And there really wasn't a lot of thought on the standards and governance and those type things. And that went on for years, data neglect, all that type stuff. And then ArcGIS Align and Enterprise came out. And on top of that, you had to learn ArcGIS Pro. So your tower's leaning and you're barely hanging on and no new people came in but now you have all these other people you have to work with. And this is a slide from a presentation I did it's IMGIS now, I forget what it was called back then. But basically this was back in 2015, I did this presentation. And this was just showing, we worked with 4 groups before we signed our ArcGIS ELA. And once we signed it, you can see our just user base just skyrocketed and how many more groups we were working with. It got pretty crazy. But we still didn't fix anything, right? You still didn't hire anybody. We didn't do anything to really do this. We, again, just flying by the seat of our pants. And now we got utility network. So they're like, oh, utility network is going to fix everything, right? I believe UN is a good thing. It's rule-based. It creates data standards. It has consistency. You can analyze the physical and logical networks together, which is an awesome thing. And it will position companies, I feel, for future enhancements, future technology. It'll put us in a good spot. But it's not a fix for GIS. And I feel like it's sold that way. That, hey, you do utility network and it's going to fix all your problems. And it's not. It's going to compound your problems if you don't do it right. If you don't have standards and governance established, you're going to struggle. If you don't have vision and strategies established, you're going to struggle. And if you're struggling with your current system and you're going to go to the utility network, you're in trouble unless you put the proper things in place to help you out. And I'll tell you this, the same thing, because of my relationship with Esri, I've got to speak with a lot of utility companies all over the world, just to talk with them when they're starting up. Esri wanted me to kind of tell them our experience. And I'll tell you the same thing I told them. 90+% of users don't care about UN. They could care less about the connected model. They just want to know where the points, lines, and polygons are. They want to know where those assets are so they can do their job. Outside of engineering and operations and things like that, they just don't care. And it's it's not a bad thing. It's just what they need. They need the basic GIS type stuff. So closing thoughts, have a plan. You know, vision leads to strategy, strategy leads to standards, and your standards lead to enforcement. Know your core layers, geometry and attributes. Who owns them, who governs them, what detail are you going down to, and are you covering all pieces of the life cycle? Location early. We don't have to be first. You know, you don't have to have, a lot of people say GIS first, which I would love, but get us in early, right? Like, I mean, planning sometimes, it doesn't always start because of location. Sometimes it's equipment. Sometimes it's, you know, electrical or gas-based. It's not always, you know, the location itself. And a big one, upstream changes have downstream consequences. So with that, oh, I take one back, one more. So in short, utility companies, location is the foundation of everything. It ties all our things together. If you don't have good location, basically everything else will start to fall apart, and you won't be able to expand your network, and you won't be able to reliably operate your network. And with that, that's all.